Hello, students. This is Mr. Morris. We're going to continue on with OnShape. Today, we're going to learn about draft. DRAFT is a term associated with when you do castings and making molds and patterns so that the casting will release from the mold once it's hardened. So you put a slight angle on the sides of the mold or the pattern. Well, you make the mold from the pattern. So they're both going to have, a slight taper to it. And the reason for that, and sometimes it's like 7 degrees, so you wouldn't be able to see it sometimes too easily with the naked eye. You'd have to measure it. So anyway, make a long story longer. You put the slight angle on your pattern, and then when you make your mold from your patterns, a lot of times I used to work for a company called Howmet in Hampton, and we made titanium castings. And so when you make the pattern, right, usually out of wax, you make a sand casting, and what happens is the wax pattern has a slight taper to it. Or you dip it into a ceramic slurry, you make your mold. It's going to also have that draft angle. And then when you pour the liquid metal into your mold, okay, because we all know that ceramics can withstand much higher temperatures than metals. Metals will be a liquid before ceramic will, okay? Um, it's going to release the part much easier. Okay. It's going to release the part much easier. All right. So I am recording. I'm going to share my screen. And again, please forgive Mr. Morris. I'm a little under the weather today. Nothing contagious. It's just very tired and just not feeling myself today. All right. So we're going to learn how to create that draft angle. So please go to, this will count as a grade. So please go to create and go to document. And we're going to call this, I believe this is exercise 9 now. We're moving up there, folks. And we're going to call this draft. Okay, so exercise 9 dash draft dash your name, your initials, or whatever you want to put there. Create. All right. So when this screen comes up, we have our normal planes, our frontal plane, our top plane, our right side plane. 99% of the time, Mr. Morris chooses the front plane, but today I'm going to choose the top plane. Okay. So today I'm going to choose the top plane. So go to sketch and we're going to click on the top plane. And when we do that, you see a sketch plane is now present, right? And it's sitting right exactly on the top plane at the origin. Now we're going to come over here to our sketching tools, and we're going to select center point rectangle. Click on that. And I'm just going to leave it in millimeters today because, Mr. Morse forgets 99% of the time to change it to English, but that's okay. We're going to drag this out, and I'm going to click, and I'm going to edit these dimensions. The first dimension I'm going to type in is 50 millimeters, roughly about 2 inches. Enter, and then we'll type in 50 again, and enter. All right. Now, that's a square. Squares are easy to make, right? So I'm going to click on the green check mark. I'm going to go to extrude, and I'm going to click inside the region. And I'm also going to make this 50 millimeters. I might as well make it a perfect cube. Green check mark. All right. So nothing, no nuclear science about this, right? Pretty simple. All right. So we just have a cube. Now we want to put a draft angle on the sides. Remember I told you, now again, and when you're making a mold, you want it to be roughly be about 7 degrees. We're going to make it a little bit larger than that so you can see it. So up here on your toolbar, come over here to this icon right here. Just kind of hover on it. There you go. Adds a draft angle to one or more faces by selecting a neutral plane or a parting line. So we're going to select, click on draft. So the neutral plane here, I want you to select the top plane. Now the entities to draft here, I want you to select, and I also want you to use the view cube to help you out here. Okay, that has put a slight 15-degree angle. You can change that. Go ahead and make it 7 degrees. Let's see what 7 degrees looks like. And click on the green check mark. All right, that's 7 degrees right there. See that? Now, if you were to rotate this upside down or rotate this 180, for example, you see the tapered set. If you were pulling this out of a mold, it's going to release better. Also with forgings, when you forge something, right? Or even when they're forming plastics, you put a cup. You've seen a cup you drank out of? Look at a cup. Usually the cup has a slight what? Draft angle to it. Why? So it will release from the mold easy or from the die. Okay, you understand what I'm saying by the cup? Next time you go home, look at a cup, a plastic cup. Look at the sides. They have a slight angle to them. That's called the draft angle. And what happens when they're manufacturing these cups, the die where they form it has a slight angle there. So it will release from the, otherwise, if you make it perfectly vertical, guess what? It may not come out of the mold very easily or the die. You see what I'm saying? Yes or no? Okay. All right, so we have this part. It's very simple, right? So now what I want to do is we are going to make a drawing because I want to show you also, we were talking about tolerances yesterday. What is a tolerance? A tolerance is a variation in a dimension. I gave you an example. If I said 1 inch plus or minus the thousandths, it could be 1.001 or it could be 0.999. There's a variety of ways to do that on your drawing. So our geometry is not very complicated. I've done this intentionally because I really want to show you how to use some of these other tools, okay? Now, speaking of tools, what tools have we used? We've used extrusion. We've used revolve. We have used sweep. We have used loft. We have used thicken. We have used fillet. We have used chamfer. We just did draft. We haven't done rib yet. Okay. We've done shell. We've done hole. And we've done thread. I haven't done these two yet, linear patterns or circular patterns, but we're going to do it. Right? We're going to do that. And then mirror. So we're moving along. We're getting through the tools. We have 8 days left after today. So I believe we'll do it. Okay. All right, now we want to make a drawing. You go down here in the lower left-hand corner. Well, before we do that, I guess you can turn off the planes if you want to. You can just highlight the planes and, you know what I'm saying, just click on the eyeball and turn it on. Come down here to the plus sign, click on the plus sign, and we're going to go to create drawing. And then click on the template that you're going to use. Select OK. I just left it blue. You could change it whatever color you wish. I'm going to click on the part. I am going to leave it 1:1. Okay, so we're going to do the standard 3 views and isometric. So click, go up, click. All right, now, see, we're up here as the projected, we're still in that mode. So click here and you can drag your side view here. And then if you want to, we're still projecting. If you want to do your isometric, you kind of go off of the 1 o'clock position and just drag it over here. Click. All right, escape. Were you able to do that? Very easy, right? I knew that you knew how to do that. So that's nothing. What's new is the draft. So you know how to do the draft angle. Um, and I'm going to show you how to put some dimensions on here and some tolerances and so forth. Come up to the isometric view, do a right click in there, and we want to go to show hide, and we want to select show shaded view. All right, it's shaded. Now, I want to just play with the angle tool. Sometimes it's a good idea not to put too many dimensions on your drawing. You put the least number necessary so you don't clutter your drawing. But today I just want to practice some with some of the dimensioning tools. So we may have more dimensions than necessary. Does that make sense? To completely describe the part. But I want you to practice using some of these dimensions, okay? So go ahead, please, and come over here to your dimension tool right here. And just click on dimension. And click this point and this point and drag it down. Now, that's 1.969. If I hit the escape button, there's no tolerance associated with that, right? No tolerance. Go ahead and double click on that. And over here is your tolerance tool. See, there's our base dimension right here. This is our base dimension. Come over here, click on the tolerance tool. And by the way, I think we're in millimeters, aren't we? So, but it seems like it's dimensioned in inches. That must be inches there, okay? Because remember, we were dimensioning in millimeters. So we may have to change this to millimeters. See, I changed it to millimeters here, okay? Make sure you click down. I didn't realize it did that either. I mean, I thought once I set it, it was going to stay in inches, but it didn't. I mean, millimeters. So click on millimeters. Now go back to this one. Click on this. You can have you can have no tolerances. You can do symmetrical. Okay. Now symmetrical, look, it's got 50.000 millimeters plus or minus how many millimeters. Right here is where you add that. Let's put I don't know, let's put 6 millimeters. Or we could say 0.006. That's very, very small. Um, I'm going to put 1 millimeter. So 50 millimeters plus or minus 1 millimeter. And then just click anywhere on your screen. Look at that. Zoom in 50 millimeters plus or minus 1 millimeter. So it could be what, 51? Or it could be what, 49? You see that? But look here, Bill, this is symmetrical. That means it's plus or minus one. It can go 1 millimeter higher or 1 millimeter smaller. That's symmetrical, right? Now, let's do one where you have a deviation. Okay, so let's go to the dimension tool again here and click on dimension. Click here and here. All right, as that's there, it's in inches, but we don't want it to be in inches. So click on that little right here. Click on that little box there. All right, click on that. And we want to change it to millimeters first. And then we want to click on this little box. And let's make a deviation this time. Now deviation, let's make it 1 millimeter or 2 millimeters to the positive and 1 millimeter to the negative. All right. And then click anywhere on the screen. Now, you can see we've got to move this a little bit, right? Because we're on top of the part. What does that mean? Can somebody tell me what that might mean based on what I said here? This is a deviation. Okay. So we have this dimension and this dimension here. One is symmetrical, one is a deviation. Does that make sense? Now let me show you another one. Okay. Again, we're putting a lot of dimensions here. They're superfluous, means we don't need this many dimensions, but I'm doing it to show you how to use the tolerance tool. Okay. Are you with me, Riley? You see what we're doing? All right. So we're going to go to dimension here. Again, we don't need to mention all these dimensions, right? Click here, click here. Might change it to millimeters again. This time we're going to change it to limits. Now when you do limits, your top dimension, you might have it as 50 point or 51.000, or actually make it 52. And then make this one 51.000. I don't know why that's. Did y'all get the same thing I got here? Huh? You did? Let's see what's happened here. We wanted limits. 52. Tell you what we're going to do. We're going to erase that dimension. We're going to come back to it. Let's go to, I don't know why it did that. We definitely want it to be millimeters. Oh, okay. I see. It's a plus. Okay. So make this 1.000 or 2 rather. And 1.000. All right, I see what it did. Click now. See what it did? That's the maximum it could be. That's the minimum. That's called the limits. So if you see stacked dimensions like that, these are stacked. A lot of times you'll see a line going through it right here. Why did he give you? Because if you are in between these two, you're good. If you're right at 52, you're good. If you're at 53, you're going to have to remove some material. If you're at 48, you're screwed because you might not be able to add no material to it. 99.9% chance you're not going to be able to add no, but you have to start over. Scrap the part, okay? But look at the three different methods, right? This is symmetrical because it's 1 inch. I mean, 1 millimeter plus or minus. This is a deviation, right? And these are your limits. You see the differences in the ones? All right, I just wanted you to see that. Now, if you wanted to put an angle dimension here, we're going to come back to dimension. Look, click on line to line angular dimension. Now, you can click on these. You learned this yesterday. We kind of did this. Click, but you can put, look, you can put a tolerance also with an angle, and we can make it limits or symmetrical, and it could be plus or minus, 1 degree. All right, click. See that? So it could be 84 degrees or what? It could be 84 degrees or what? It could be 83. 83 is perfect. But what can it be? Can it be 84 degrees based on that tolerance? Can it be 82? Can it be 83.5? Can it be 82.5? Yes. You see what I'm talking about? That's your, okay. Now that's the angle there. You can look, you can come over here, put an angle, and you could just, okay. So again, we're putting more dimensions than we need because I'm just trying to get you uh, to see what's going on here. Now let's put a vertical dimension here. Go to vertical. Click here, here. Now we know that's not right because we're supposed to be in what? In millimeters. So it's also 50 that way, and we'll make it symmetrical. Just make it symmetrical. Now I got to go back and edit that dimension. So you have to hit escape because it didn't do right. Now click. Now it should be all right. You can also have an angular dimension. Look, you can have an angular dimension. See that? I like I'd rather not have the angle dimension on the part if you can keep from it. It's better to take the angle dimension off. I'm gonna put a dimension here. And if you can't see it, you can come up here and look at what I got. For this angle dimension, we're going to have a symmetrical and be plus or minus. You can make I tell you what, let's don't do symmetrical. Let's do deviation. So you can be 1 degree larger or let's say 2 degrees larger and only 1 degree smaller. Right? Click. See that? That means it could be what, 16 degrees or what, 13, right? You can be in that range or anywhere in that range. Any questions? All right. Let's go ahead and start filling this out. Go to your text, click on A, come down below the view, click, and we're going to type in top view. I'm going to highlight it, make it bold, underline. So I wouldn't show this drawing to anyone necessarily because it's not, it was this practice, right? Dimensioning. Okay. It was just practice. I'm gonna right click here and copy, come down here, right click, paste. Come over here, right click, paste. You gotta drag it. Landon, when Zaya gets back, if you wouldn't mind helping her catch up because you're pretty good with this. We're going to type in front view here. Oops, sorry. Front view. Right side view. And this is ISO view. ISO view right there. Click on the green check mark. All right. I'm going to show you also how to bring in a table. And this table has no relationship to this drawing at all. Well, we could make it somewhat related. Click on this right here. You see this? Click on table right here. And how many rows? I want to say, we'll call it AB. We can always add more rows, but I'm going to make it 2, 3. I'm going to make it 3 rows. And I don't know. I think I'm going to leave it. Let's see. Height, width, and depth. Okay, we're good with that. Columns, I'm going to make it 4. Click. Okay, and I do the check mark here. Now we have to fill in the table. Put the letter A here. Put the letter B here. Put the letter C here. All right, now you can also double click on these and change the justification to make it centered, right? Just like you would do in Excel. Any of y'all used Excel before? You might have a need for a table. This angle, he's going to come show you. So, what we're going to do here, let's just, we'll call this dimension. We're just playing around with the table here. So we're going to give the base dimension and the max and the min, okay? So that's what we're going to do. So we'll call this dimension A. We're just practicing here, okay? Click in here. And we're going to let this be the base dimension, or yeah, is that. And we can make the maximum dimension, right? And we can make the minimum dimension. So here, the minimum dimension would be 49. Mr. Morris, where are you getting those numbers from? Right here. So 50 is the base dimension, the maximum dimension, and the minimum. Now, I don't play with tables too much, but if I come in here, I can do a continuation like that, but I don't really want to do that. I really want to put a table above it. Let's see if I can do that again. Maybe. Anyway, I was going to put that's okay. I was going to put above the 50. I was going to put that was the base dimension, and this was the max or the min. I wonder if I can come in here. I was seeing if I can add a row above table properties. No. Well, I guess in your planning, you need to make sure you account for that. I would have had another row on top of the title blocks, the title and the table, name of the table and the border, stuff like that. All right, dimension B can be the angular dimension. So this would be 83, right? Degrees. The max would be what? 84. You see that? And the min would be what? 82. All right. Yeah, are you with me? And then for this dimension here, we would call this C. I'm just showing you how to make a table. I told you that this is not really associated with what we've done here. We're just practicing some things. We're practicing how to use a table. If I make this 14, then the max could be what? 16. And the minimum would be 13. Did I do my math right? All right. This is how to make a table. And yes, you do need tables every once in a while when you're drawing. So what did we learn today? For this, we're going to do the title block still, but let's review what we learned. We learned how to create a draft angle, and I gave you some applications for that. I gave you making molds and castings. And then I said also with forgings, if you come down and you press two pieces together and it's at a 90 degrees angle, it's not going to come apart. It's not going to come apart. Okay. It's going to be stuck in your tool. If it's a 90-degree angle, you have to have a slight what? Draft angle. Does that make sense? We came in here and I said, let's practice dimensioning today. If you were to turn this in for a drawing, I'd probably give you a bad grade on it because I don't need that many dimensions. I was not worried about the number of dimensions. I was worried about, do you know how to use the tolerance tool? And you do. You should now. This is symmetrical. This is deviation. These are limits. They all mean the same thing. Okay. except for this one. These two here, you can see that really is giving you the same thing, right? Aren't these two giving you the same thing? 52 and 49. See that? This is not. This is giving you 51 and 49. Okay. And if you want to review one more time how to put an angle on something, it's perfectly acceptable to dimension like this too at times. That's perfectly acceptable sometimes to do that. It's also acceptable to do this at times. That. Now notice something. These two dimensions here have to equal what? 180. These two dimensions here have to equal 180. Any questions? All right, let's go do our title block here and check by you. And then the date. Approved by, now you put me here, right? Let's say I don't have time to check this today, but I am going to check it today. But, a lot of times in the real world, they're not going to check it on the same day that you do it. So this might be the 25th, or for example, who knows? Just letting you know, that's not always going to be the same date. Once this person here signs off on it, whoever it is, it's ready to be released, right? You have someone who draws the drawing. The person to check it may not be you. It may be your immediate supervisor. Then they sign off on it, right? And then the approval comes from your supervisor's supervisor. He signs off on it. So it's a check and balance. It's a check and balance, correct? All right. So right here in the title, VPCC, delete the dashes. That's not where I wanted that. Let me undo that. Okay, so it's VPCC. Right here, we're going to put draft angle and tolerances. Let's see if that's going to fit. It fit. Draft angle and tolerances. And then what did we put down here? Do you remember what we put on the third line? Oh, we can just put CAD 120. Any questions? So you have your model. There's your model, very simple, but I was just trying to show you the draft angle here. That was it. That was all I really wanted to do, is show you how to create that draft angle. And like I said earlier, we've covered extrusion, we've covered revolve, we've covered sweep, we've covered loft, we've covered thicken, we've covered fillet, we've covered chamfer, and we've covered draft. We haven't done rib yet. We've done shell, we've done hole, and we've done thread. So now we're going to start getting into the patterns here soon, and some of these more advanced applications up here. All right. We'll get as far as we can. Y'all get this today? All right, I'll be coming around and checking just a minute. What I want to do now is I want to stop my share. You want to does anyone want to take a picture of this before I shut it down? No? All right, say goodbye here for online.